Thanks, Angus and the Colonel, for inviting me here today. I feel that my presentation is going to be a bit sad after the last one. It was really quite an amazing presentation. My brain's rattling with the possibilities of what we could be doing with automation in our orchards. But anyway, my talk today is on biochar. As you probably know, soil management, soil health and loss of soil carbon is a global issue within agriculture, and perennial horticulture's no different from that. Our soils have issues with soil carbon, as Roberta will show you later in the next presentation, and they're particularly hard to manage, particularly under bare fallow type management systems. In the last 10 years, biochar has been loudly forwarded and promoted as a means of improving soil carbon and a whole range of soil properties. And you can see here, this is some of the things that biochar has been claimed to be able to do. And this has come from some of the bigger and more respected biochar type organisations, the Biochar International Organisation and the likes. And some of the claims that we'll target in on is reducing soil acidity, increasing soil moisture, increasing water retention, improving soil structure, increasing the number of beneficial microbes, stimulating microbes, increasing productivity in crop yields, reducing leaching of nitrogen into groundwater and reducing fertiliser use. Basically, it's a one-step cure-all for everything that's wrong in your soil. So we set out to test it. Okay. One of the issues with biochar is that no two biochars are the same. So what is biochar? I mean, biochar is basically just any organic material which has been burnt in a low oxygen environment to make charcoal. Okay, so the common ones are things like crop residues, wood, but also things like pig slurries and treatment waste slurries and things like that. It's basically anything you can chuck in an oven and cook in low oxygen environments. And so I find it exceptional that all these different sources of products would have the same effect in all soils everywhere. Okay. So the trial we set up was Mountain Creek in Tassie. In Fuji, it was a replant situation where we had an independent biochar control. Hold on, that's my laser. As control, a biochar, compost, and then a biochar and compost. But most of the work I'll talk about is around this just biochar stuff compared to the control. But look, you can see the site, and it was replanted. The biochar that we actually used came from Pacific pyrolysis in New South Wales, and it was wood waste from mostly acacia. They cleared vegetation under a set of power lines, and they put that through pyrolysis at 550 degrees. Okay, so it's a hardwood biochar. Okay, lots of data and stuff. What we found was we had no effect on yield. Okay, biochar treatment. Okay, fruit weight, yield efficiency, number of fruit compared to the control, we had no effect. We had no effect on yield efficiency. We had no effect on the number of fruit, the fruit weight, or the blossom density. The only thing that we had a significant difference was in the stem girth, which increased with the biochar compared to the control. Okay, otherwise, all other parameters were not significant. Tree physiology. We had no significant effect on the total leaf area, photosynthetic capacity, leaf nutrient concentration, or sap flow as a measure of daily water use, or gas exchange. Okay? It's not looking good, is it? This was my part of the work. I should say there's been a lot of people involved in this work. We've had a lot of different fields of science contribute to this question. This was my stuff. Scanning electron micrograph of the biochar. And you can see it's got these bigger holes and a whole lot of quite small holes. But we had no effect on field capacity. Okay? The permanent wilting point, the plant available water, soil moisture, no effect on aggregate stability, or meso or microporosity, the pores that actually hold and store water. But we did have a lower bulk density and we had a higher total porosity, and the infiltration rate was higher at saturation. And that was because we had more worms in the biochar treatment, and they drilled big holes. And those big holes allow for greater infiltration, but not storage of water. Okay? Soil carbon. Well, you chuck carbon in soil, you get more carbon in your soil. So that's not really surprising that we've got an increase in carbon. There's a difference between functional carbon that microbes consume as food that gets included in the carbon cycle to just carbon. But anyway, we increase carbon. Woohoo! Acidity. This was a really interesting one because nearly all biochars are alkaline. In fact, most ash of most things when you burn is alkaline. This one wasn't. This was really odd. It was slightly acid. Very unusual. And after 20 months, this is Roberta's work, she'll be presenting later, some other bits and pieces, we actually showed that the biochar treatment had was more acid, had a lower pH than the control. Okay, so complete opposite of everything you ever read about biochar. But anyway, that was our biochar. This is another bit of our work. We had things called flux meters installed beneath the A horizon, beneath the topsoil, to measure the amount of water draining through the profile and the amount of nutrients coming through. And these are cumulative graphs, okay? So this is the amount of nitrogen applied. See that big spike? That's what happens when you put on 2 shovel loads of chicken manure, as well as your NPK and other things during the year. So it had manure, it had NPK, and it had fertigation as well. And you see that's how much nitrogen went on over the 3-year monitoring period. This is the amount of nitrogen which actually came through as the biochar, and this one the control. So we had more nitrogen leaking through the topsoil under biochar than we did in the control. And note, we're losing around half of the nitrogen that we've put into that soil. Phosphorus, well, phosphorus is very sticky. It doesn't move through the soil readily, but you'll see that the biochar again leached more phosphorus. And potassium, we actually had more potassium leached than we actually applied, which is because the biochar contains potassium, and you've also got release of potassium in the soil and other sources, okay? So we had almost, complete loss of all the potassium that was applied. So in terms of statistics, biochar significantly increased the phosphorus concentration, the phosphorus leaching, and the potassium leaching. Nitrogen was a 51% increase, but it wasn't significant. High degree of variability in the data, unfortunately. Okay? And part of it was that biochar resulted in just more water moving through the soil profile, which was that issue of the worms. It just led to more water going through, so greater loss of nutrients. This work's about to be published. I hope it causes a bit of a stir. We'll see. In terms of the microbes, this stuff was done by our Kiwi partners. I find this absolutely fascinating. So we're looking here at basically the abundance, how many bacteria you've got of different bacterial groups. And you can see we don't actually have any real differences. But over here, somehow this slide's got a bit skewed. Over here, this is really interesting. This is like mapping out the different types of microbes in the soil. And you see that we actually get a grouping in the biochar which is separate to the compost and the control. So we are influencing the population of microbes. We haven't influenced the abundance of the bacteria, but there's something going on. What does it mean? Don't know what it means. It's hard to know what it means. Roberta will talk a bit more about it. Okay, so there's the biochar one. So we started off with this premise of all the things that biochar was going to do to fix our soils, because it works everywhere, on all soils, with all biochars. And we start going through this list. Things aren't looking so pretty. We didn't reduce soil acidity, we didn't increase soil moisture, we didn't increase water retention. Yeah, look, there was an improvement in soil structure, particularly in density, but it wasn't a particularly useful improvement in soil structure. We didn't increase the number of microbes. Well, bacteria was the thing we measured. Yeah, look, we had an effect on the soil microbes. We did influence the communities. We didn't increase productivity and yield. We didn't increase the leaching and nitrate to ground. Well, in fact, well, we did actually increase it, didn't we? But it wasn't significant. And there's no evidence to say that it would reduce fertiliser. And so these statements that we see about biochar being able to improve almost any soil, simply not true in this case. What we do have to bear in mind is that, you know, this is a high input system. There's a lot of nutrients and a lot of water. If it was a low input, highly stressed, would have we seen a difference? Don't know. Didn't test it. Wasn't able to test it. And there's no doubt that from the literature that some biochars work in some soils, in some climates, in some production systems for some soil properties. But we just can't take it as a blanket statement of the benefit of these products. And what we tried in our soil, in our production system, found the results that you can see here. I really want to thank everyone involved in this work. It was actually a really great team of people to work with, one of the more enjoyable work experiences I've had, particularly our collaboration with our Kiwi researchers. A really great bunch of people, and many different fields of science coming together on the one issue and the one site was a really good opportunity. Thank you.